Hi, my name is Adrina and my video lecture is on the trigonometric form of a complex number. First, you need to know how to solve for the absolute value of a complex number, which is given right here. A plus bi equals the square root of a squared plus b squared. The trigonometric form of a complex number is z equals a plus bi, which is going to be changed into z equals r multiplied by cosine theta plus I sine theta. So in order to be able to transfer a complex number into its trigonometric form, you have to solve for the modulus, which is r. And the formula for that is the absolute value, which was the square root of a squared plus b squared. And you have to be able to solve for theta, which will be the tan inverse of b over a. And that will be called example 1, we have to find the trigonometric form of this complex number, negative 7 plus 4i. Your first step is you always want to make sure that the number with the I is your b term, because if you have it backwards, you'll get the problem wrong. So, as it says up here, we want to solve for our r and for our theta. So r, we do the square root of a squared plus b squared. So we have negative 7 squared plus 4 squared. And you're going to take the square root of that, you could use your calculator, and you get r equals the square root of 65. Then we have to solve for our theta. And as it says right here, theta is the tan inverse of b over a. So we get theta equals the tan inverse of 4 over negative 7. You put that in your calculator and you get theta equals negative 29.7. Okay, for example 1, we have to find the trigonometric form of this complex number, negative 7 plus 4i. Your first step is you always want to make sure that the number with the I is your b term, because if you have it backwards, you'll get the problem wrong. So, as it says up here, we want to solve for our r and for our theta. So r, we do the square root of a squared plus b squared. So we have negative 7 squared plus 4 squared. And you're going to take the square root of that, you could use your calculator, and you get r equals the square root of 65. Then we have to solve for our theta, and as it says right here, theta is the tan inverse of b over a. So we get theta equals the tan inverse of 4 over negative 7. You put that in your calculator and you get theta equals negative 29.74. So you're going to plug in your r and your theta into this equation right here. And you get z equals the square root of 65 multiplied by cosine negative 29.74 added by I sine negative 29.74. So basically what you're going to do is you're going to plug in your values from these into this equation. So we have r1, r2. This is our r1 and our r2, so we're going to multiply those together. Then we have our theta 1 plus theta 2. That would be 310 plus 200, and you're going to plug that in here. And same thing over here, the theta 1 plus theta 2. And you're just going to plug that all in. Okay, and then when you add these up, it's going to be greater than 360. So you want to subtract 360 from the sum of these two numbers, and you're going to get 150. And then you could look on your unit circle and find the cosine of 150, which will be negative square root of 3 over 2, and the sine of 150, which will be 1/2. So you're going to simplify that. You're going to get 15 multiplied by the negative square root of 2 added by I multiplied by 1/2. Distribute this 15 into this, so you will get your answer of negative 15 multiplied by the square root of 3 divided by 2 added by 15 divided by 2 multiplied by I. You want to make sure it's in standard form, which is a plus bi. For my next example, I will show you how to solve for the quotient of two complex numbers. So the formula for solving for the quotient of two complex numbers is r1 divided by r2 multiplied by cosine of theta 1 minus theta 2 added by I sine of theta 1 minus theta 2. So here is our example, and looking at it, we have to realize that this is r1, this is r2, which will be right there. This is theta 1, that is 2, theta 2, and that is also theta 2. So we're going to plug in our r1 and r2 and theta 1 and theta 2 into this equation for the quotient. And when you plug it all in, you need to simplify. So we get cosine of theta 1 minus theta 2, and that will end up being 2.2. So once you end up with 2.2, you need to solve for this using your calculator, because you cannot find this on your unit circle. And once you do that, you're going to need to distribute this 5 over 4, and that will get you this answer right here of 1.25 added by 0.05i. For this next example, You have to use the formula, and what you mainly need to notice is that with this exponent of n, it was turned into an exponent for r, and then it became part of the cosine and part of the sine. So what you're going to do is you're going to plug in whatever that n is into this equation as it is. So here's our problem, and we were given the exponent of 4. What the formula says, this is going to be the exponent of 4, and then you're going to put a 4 here, right here. So then you're going to multiply these, and you're going to get 60. So cosine of 60 and sine of 60. You could go on your unit circle and solve those. So you're going to get 3 to the 4th power, which is 81. And then you're going to distribute the 81 to the cosine of 60, which is 1/2. And then the sine of 60, which is root 3 over 2. And you're going to get the answer of 81 over 2 added by 81i root 3 over 2.